Imagine a place where your breath can freeze into tiny crystals before it even leaves your lips. A place so cold that metal can become brittle enough to crack like glass. Now imagine someone blindfolds you, drops you there, and removes the blindfold. You might swear you were no longer on Earth, but you would be. This place is Antarctica. And here is the uncomfortable question. If part of Antarctica becomes unstable, could ocean water begin threatening major coastal cities within this century? Could places like New York, Mumbai, Kolkata, or Chennai face a very different future? At the edge of Antarctica sits one of the most closely watched glaciers on Earth, Thwaites Glacier, sometimes called the Doomsday Glacier. And there is another date connected to Antarctica that often gets misunderstood: 2048. In this documentary, we are going beneath the frozen surface to explore the hidden world of Antarctica, its extreme climate, buried mountains, strange lakes, ancient ice, blood falls, powerful winds, hidden volcanoes, and the glacier that could influence future sea levels. Welcome to the hidden world of Antarctica. On the 21st of July 1983, scientists at Vostok Station recorded a temperature of -89.2 degrees Celsius, or about -128.6 degrees Fahrenheit. It remains the lowest temperature directly measured at a weather station on Earth. Satellites have detected even colder temperatures on parts of the Antarctic ice sheet, but those were surface estimates rather than direct weather station measurements. Antarctica can feel almost completely silent. There are no cities, highways, forests, or crowds. Only ice, wind, mountains, darkness, and enormous distances. But this frozen silence can be misleading. Antarctica is constantly changing. Its glaciers move. Its ice cracks. Ocean water flows beneath floating ice shelves. And scientists are watching these changes carefully because Antarctica holds enough frozen water to dramatically affect global sea level over long periods of time. There is also a political story. Antarctica is governed through the Antarctic Treaty System. The original Antarctic Treaty established the continent as a place mainly for peaceful activity and scientific research. Another agreement, the Environmental Protocol, bans mineral resource activities other than scientific research. You may sometimes hear that this protection automatically ends in 2048. That is not correct. The treaty does not suddenly expire in 2048. Starting in 2048, however, countries can request a review conference for the Environmental Protocol under specific conditions. Even then, changing the mining ban would be extremely difficult and would require major international agreement. So 2048 is not a countdown to an Antarctic resource war. But Antarctica will almost certainly remain strategically important because of science, climate, resources, geography, and international politics. To understand Antarctica, we first need to travel far back in time. Hundreds of millions of years ago, Earth's continents were arranged very differently. Many southern continents were once connected in a giant landmass called Gondwana. Antarctica was part of it. India, Australia, Africa, South America, and Antarctica were once connected through this ancient supercontinent. And Antarctica was not always covered by kilometers of ice. During warmer periods in Earth's past, parts of Antarctica supported forests, rivers, and ecosystems. Fossils and geological evidence show that plants and animals once lived in environments that would seem impossible there today. But the continent slowly moved. Tectonic plates shifted. India moved north and eventually collided with Asia, helping create the Himalayas. Australia separated from Antarctica and moved north. South America also moved away. Antarctica became increasingly isolated around the South Pole. That isolation changed its climate. One major part of this story is the Antarctic Circumpolar Current. This massive ocean current flows around Antarctica. Because there is no continent blocking its path, it can circle the entire continent. It helps isolate Antarctica from warmer ocean water and plays a major role in the global climate system. As Antarctica became more isolated and Earth's climate changed, large permanent ice sheets developed. Over millions of years, much of the continent became buried beneath ice. Today, Antarctica is one of Earth's strangest contradictions. It contains most of the planet's fresh water in frozen form, yet it is also the largest desert on Earth. That sounds impossible until you understand what a desert really is. A desert is not defined by sand. It is defined by very low precipitation. Much of Antarctica receives extremely little snowfall each year. Some areas, especially the McMurdo Dry Valleys, are among the driest places on Earth. These valleys can look more like Mars than Earth. They contain exposed rock, frozen ground, almost no vegetation, and extremely little moisture. Because of these unusual conditions, scientists have used Antarctic environments as analogs for studying how life or equipment might behave in extremely dry, cold environments on other worlds. But cold is only one danger. Antarctica also has some of the strongest winds on Earth. One important type is called a katabatic wind. Here is how it works. The Antarctic interior is high and extremely cold. Cold air becomes dense and heavy. Gravity pulls that dense air downhill toward the coast. As it moves down steep slopes and becomes channeled by the landscape, it can accelerate dramatically. In some locations, Antarctic winds have reached extraordinary speeds. These winds can create dangerous whiteout conditions, move snow across the surface, and make already extreme temperatures feel even more brutal. Antarctica may look frozen and motionless, but its ice is constantly moving. The enormous ice sheet is heavy enough to slowly deform under its own weight. Glaciers and ice streams carry ice from the interior toward the ocean. Some move only slowly. Others move surprisingly quickly by glacial standards. The ice also cracks. It shifts. It produces deep sounds. Sometimes, sudden movement within glaciers or ice shelves can create seismic signals, sometimes described as ice quakes or cryoseisms. The continent may look still, but it is always moving. Now imagine living there through winter. At some Antarctic research stations, the sun disappears for months. Researchers live in isolation with the same small group of people, while temperatures remain extremely low and weather can make travel impossible. This environment affects both the body and the mind. Scientists have studied what is sometimes called winter over syndrome. People may experience sleep disruption, reduced concentration, changes in mood, fatigue, memory problems, and social stress. There is even an informal phrase, the Antarctic stare, sometimes used to describe the distant or unfocused behavior that can appear during long periods of isolation. Antarctica is therefore not just physically challenging, it can be psychologically demanding as well. But the most fascinating part of Antarctica may not be what sits above the ice, it may be what lies below it. If you could somehow remove the Antarctic ice sheet, you would not find a simple flat continent. You would discover enormous mountain ranges, deep valleys, basins, lakes, and rugged terrain. One of the most famous buried mountain systems is the Gamburtsev subglacial mountains. They lie beneath thousands of meters of ice in East Antarctica. Some peaks are comparable in scale to major mountain ranges elsewhere on Earth, yet no human has ever stood on most of them. Scientists study them using radar, seismic measurements, gravity data, and other remote sensing methods. Antarctica also contains volcanoes. Some are visible. Mount Erebus, for example, is an active volcano rising above the ice. Researchers have also identified many volcanic structures beneath the West Antarctic ice sheet. That does not mean Antarctica is sitting above one giant ocean of lava. But geothermal heat from Earth's interior can influence the base of the ice sheet in some areas. Where the base becomes warmer, liquid water can form beneath the ice. That water can affect how easily glaciers slide over the ground. And this leads us to one of Antarctica's strangest places, Blood Falls. At Taylor Glacier, a dark red flow sometimes appears against the bright white ice. It looks almost like blood pouring from a glacier, but it is not blood. The color comes from salty water rich in iron. When that iron-rich water reaches the surface and interacts with oxygen, the iron oxidizes. It essentially rusts. That creates the deep red color. The water comes from a highly salty subglacial environment that has been isolated beneath the ice for a very long time. Even more fascinating, microbes can survive in these extreme conditions. Some of these organisms live with very little oxygen and use unusual chemical processes to survive. Blood Falls is therefore more than a strange visual mystery. It is evidence that life can survive in places that once seemed impossible. That idea is important for astrobiology. If microbes can survive beneath Antarctic ice in salty, dark environments, scientists can ask whether similar environments might support life elsewhere in the solar system. Antarctica also acts like a giant archive of Earth's climate. Scientists drill deep into the ice and remove long cylinders called ice cores. Every year, new snow falls and becomes compressed. Layer after layer forms. Tiny bubbles of ancient atmosphere become trapped inside. Those bubbles preserve samples of the air from Earth's past. By studying them, scientists can measure ancient concentrations of carbon dioxide, methane, and other gases. They can also study dust, volcanic ash, chemical signals, and isotopes in the ice. Some Antarctic ice cores preserve climate information, stretching back hundreds of thousands of years. This allows scientists to compare today's atmosphere with ancient climates. And the record shows something important. Earth's climate naturally changes. But the current rise in greenhouse gases is happening extremely quickly compared with many natural changes recorded in the ice. Antarctica is already responding. Some parts of the continent are changing more rapidly than others. West Antarctica is particularly important because much of its ice rests on bedrock that lies below sea level. This makes some glaciers vulnerable to warmer ocean water. For decades, scientists once imagined the underside of Antarctica as completely frozen. We now know it contains an enormous hidden water system. There are hundreds of subglacial lakes beneath the ice sheet. Water can move between some of them. One of the most famous is Lake Vostok. It lies beneath roughly 4 kilometers of ice. The lake has been isolated from the surface for an extremely long time. Researchers have studied ice associated with this environment for signs of microbial life. Although claims about exactly what organisms live directly in the lake remain scientifically challenging because contamination is difficult to rule out. Still, Antarctica has clearly demonstrated that microbes can survive in many subglacial environments. That makes scientists interested in icy moons such as Europa and Enceladus. Those moons may contain oceans beneath thick layers of ice. Antarctica gives scientists a natural laboratory for understanding how life might survive without sunlight. But now we come to the part of Antarctica that has received the most dramatic attention: Thwaites Glacier. Thwaites is located in West Antarctica. It is enormous, roughly comparable in area to the U.S. state of Florida. The glacier drains a huge section of the West Antarctic ice sheet into the ocean. Scientists are concerned because warm ocean water can reach underneath parts of its floating ice and grounding zone. This can increase melting from below. The glacier has already been losing ice. Why does this matter? Because Thwaites currently contributes to global sea level rise. If the entire glacier were eventually lost, it could raise global sea level by roughly 65 centimeters, or a little over 2 feet. But that is not the full concern. Thwaites interacts with a much larger part of the West Antarctic ice sheet. If major retreat eventually destabilized neighboring ice, the long-term sea level contribution could be much larger. But this needs an important clarification. Scientists do not expect Thwaites to suddenly collapse tomorrow and raise sea levels by several meters overnight. The processes involved would unfold over decades, centuries, or potentially longer. The real danger is not one giant wave. It is a long-term change in coastlines. Even smaller increases in sea level can make storm surges more destructive, increase coastal flooding, accelerate erosion, and threaten low-lying communities. That is why scientists watch Thwaites so closely. It gives us information about what future generations may face. And this is where Antarctica becomes much more than a distant frozen continent. What happens there does not stay there. Changes in Antarctic ice affect global sea level. Antarctic ocean circulation influences climate. Its ancient ice records Earth's atmospheric history. Its ecosystems show how life survives extreme environments. And its political status demonstrates what international cooperation can achieve. Antarctica is the world's largest desert. It is also Earth's greatest frozen freshwater reservoir. It is a climate archive, a biological laboratory, a geological mystery, and one of the most important places for understanding our planet's future. For millions of years, Antarctic ice has preserved evidence of Earth's past. Now, that same ice is helping scientists understand what could happen next. The lesson is not that Antarctica is a ticking bomb that will suddenly destroy civilization. The science is more complicated than that. The real warning is slower, but no less important. Glaciers respond to warmer oceans and atmosphere. Ice loss affects sea level, and decisions made today can influence how much change happens during the coming centuries. So the next time you look at a globe and see that huge white continent at the bottom, do not think of it as empty space. Under that ice are mountains no human has ever seen directly, lakes hidden from sunlight, microbes surviving in extreme conditions, records of ancient atmospheres, moving glaciers, volcanoes, and clues about the future of Earth's coastlines. Antarctica may look silent, but scientifically, it is telling us an enormous story. The question is whether we are willing to listen.